Shotgunning is the act of rapidly consuming a canned beverage through a hole punctured in the side of the can. The typical manner in which the puncture is created can be dangerous due to the exposed aluminum, so we designed a handheld, hand-powered solution that will reduce the already high risk of this act. Our mechanism is a 4-bar linkage consisting of a driven slider and a rotating arm about a fixed pivot position. Given the handheld and portable requirements for this device, we designed it to be 15 inches long and made the frame with a lightweight plastic, while the linkage is made of a steel to withstand the stresses involved with puncturing the can.
The kinematic analysis is used to determine the relationship between the horizontal input and the angular output. This includes determining the radius, puncture distance, and slider length. These attributes are determined using a simple crank and slider vector loop. The vector loop consists of the bottom portion of our mechanical device. Pin C is fixed, while pin A slides horizontally. Using these equations and optimal puncture location, a radial distance of 2 inches was determined, and a length of 2.44 inches for the slider link was determined to produce an angle of 33 degrees.
Force analysis was performed to analyze forces exerted on each link and joint of the rapid can opening device. The analysis provides reaction forces on each joint, which in turn provide a breakdown of expected forces on each joint given the required load. The calculations utilize free body diagrams to identify the location of the forces. Assuming friction at all joints can be neglected, the calculations were performed at the specific instant in time in which acceleration and required torque was equal to the minimum required force to puncture the beverage can. The force required to puncture the can was calculated to be 37.5 pounds. The analysis confirmed that the mechanism would supply a force of 112.7 pounds.
The purpose of stress analysis is to locate the point where the system will fail, then to calculate the expected load which causes the failure to occur. This specific device will most likely fail in the yellow highlighted area. The force resulting from the resistance of puncturing the can will partially be directed along the blue beam. This will create a bending moment about that highlighted point. Equation 1 multiplies force by length of the beam to find the moment. Equation 2 is the bending stress at a point. And equation 3 is the moment of inertia of a square beam. Plugging in the known values, we are able to solve for sigma, which is 35.55 pounds per inch squared. This value, paired with various materials and their ultimate strength, will give us different factors of safety. The factor of safety is simply the ultimate strength over the actual stress.